Welcome to this introductory lecture on energy and sustainability. In this lecture, we will talk about what is energy and where does it actually come from, what do we use it for. We will see what the major sustainability challenges of energy supply are, and we will learn about the energy transition and renewable energy in particular. We will start with a basic notion of human needs and wants. We are people, we have needs, we need thermal comfort, we need food, we need transport, communication, and all these services are there to satisfy our human needs and wants. It's what connects us to the world around us. And these services need materials and energy for their supply, for their provision. We need energy to heat our buildings, to cool them. We need water to drink and to clean our flats and so on. So we link our human needs and wants to services and then to energy, material and land use, for example. Energy in particular is a quantity that must be transferred to an object to perform work on it or to heat it. Why is it important? Because this happens when we supply services to people. We perform work on something, so we do machining, we do transport, or we heat or cool down something. And to do these things, we need energy as a way of transforming the potential to do work from one object to another. And when we look back into human history, we see that energy has always been with our species. In fact, it's not only us, it's all living organisms that need energy to survive. In hunter-gatherer societies, people needed about 10 gigajoules per capita a year, and this is roughly the energy of the food that the people needed to eat to sustain their own bodies. And once you move on to the agrarian societies, your energy metabolism increases drastically from 10 to roughly 60 to 70 gigajoules per year, not because people ate more, but because people also had animals to feed, and so the overall energy turnover of society increased. Now in industrial societies, we have arrived at roughly 250 gigajoule per capita per year. That's 25 more as we had in hunter-gatherer society. Again, not because we eat so much more, but because we use all the services that we previously talked about, the heating, the transport, the communications, and all these services consume vast amounts of energy. So we have a lot of additional energy that we need to consume, that we need to supply ourselves with, and then we can enjoy all the services that we have in our daily lives. And we will now learn more about how this works. So we have in the 21st century in industrialized societies roughly 700 megajoules per day, whereas we have 10 megajoules of food per day. So you see that the overall energy metabolism is vastly increased beyond the metabolism of our own bodies. So our whole society needs fuels, needs materials, and all they need energy for transportation and for manufacturing and also for the use of products. So how does energy supply and use look like? We will first study a specific, highly industrialized and developed country, the USA, to understand where the energy comes from and what sectors it's used in. Here for the USA, you see on the left side the major energy sources. It's petroleum, natural gas, coal. Together, the fossil fuels roughly account for 80% of the total energy supply in the US, and you have renewable energies coming in with 11% and also some nuclear power with 6%. And on the right side, you see the end-use sector. There's a lot of energy being consumed in transportation. That's everything from riding a motorcycle to aircrafts. You have the industrial sector, that's manufacturing and material production, and you have the use in buildings, residential and commercial, for heating, cooling, appliances, lighting, and hot water. And we see that there are large sectors and there's not a clear end-use sectors that dominates the whole picture. So energy use is all pervasive throughout modern society. When we look at the time series, we see that the use of petroleum and natural gas has rapidly increased over the last 70 years, and the use of coal in the US has increased up to 2000 and then steadily declined and mostly being replaced by renewables and by natural gas. We see that renewables have surged, have increased, but still at a quite low levels, and the supply of nuclear energy has plateaued after about 1990. In the use side, we see that most sectors have steadily increased their energy consumption, mostly because the overall population has increased and also the overall service level have increased drastically. The industrial sector energy consumption has roughly stayed constant over the last 50 years. That's because many material production and other energy-intensive industries were offshore to other countries as a consequence of the globalization, in particular to China. We see a similar pattern at the global level. We see that energy consumption is steadily increasing, and here the main sectors shown are the transport sector, power, which is electricity generation, the industrial sector, and other sectors like agriculture. And we see in a slightly different breakdown on the left side that, again, the industrial sector globally is quite large, with 50% of all the energy going into producing materials and producing products. And the other half goes into transportation, roughly 1/4 of global energy use, and the last quarter goes into residential and commercial buildings. So you can see here the energy ends up in different sectors, and of course all these sectors have their own energy decarbonization and energy efficiency challenge that we will learn more about in the course of these lectures. Globally, the society was mostly agricultural until 1850, when the coal use through the Industrial Revolution really kicked in. So since then, the share of wood in total global energy consumption has steadily decreased, and the traditional biomass is now at maybe 5 or even less % of global energy use. And increase have the energy carriers coal, petroleum, natural gas, also nuclear later, and of course the renewables, hydroelectric and other renewables, which are now slowly coming in. And you can see here that coal, at least when it comes to the global share, is already slowly being phased out and replaced by other fossil fuels, which originally were harder to get, but now are more interesting because they are of a higher quality. And that's of course petroleum and natural gas. So you can see here, globally, we are far away from a sustainable energy supply. Fossil fuels still dominate the picture with 80 to 85% of total energy supply, and only in recent years the other renewables have been kicking in and slowly gaining a larger share of the total supply. So in terms of the global energy transition towards a low carbon and sustainable energy supply, we still have a very long way to go. Here in absolute terms, you see that even though the share of traditional biomass like wood has been decreasing to less than 5%, the overall supply volumes has remained roughly constant and even slightly increased. And the change has just come from additional energy consumption from coal, oil, natural gas, and later on nuclear and other renewables. So you can see the whole sustainability challenge of energy supply is a scale problem. We use a lot of energy to get all the services that we need, the heating, the transport, the communication, the materials, the stuff that we use. And this energy is mostly sourced from fossil fuels, creating a number of environmental challenges that we soon will learn more about. Now, energy supply and use is not an environmental issue in itself. Energy is a rather neutral quantity. But of course, to harvest energy, we need to interfere with the natural environment. We need to clear cut forests to get the wood for use it for energy material purpose. We need to clear land for open pit mining. We need to interfere with the oceans to get tidal wave energy or offshore wind power and so on. So energy that we use always comes at an environmental cost, which is very logical, because we as humans, if we consume energy, it means it's taken from the environment. It's not available to other species or just left to the Earth systems alone. So we interfere with the environment when harvesting energy, and that potentially can cause major problems, in particular if you look back to the scale at which we now use energy. The other challenges to energy use is the social justice related to energy use, especially the problem of energy poverty, that we have too many people still on this planet who lack access to basic energy services like decent heating and cooling, or hospitals that run on electricity, for example. So we have framed all these problems into a concept that we call sustainability, and the process towards sustainability we call sustainable development. The idea is that we want to achieve a decent standard of living for everybody on this planet without compromising the needs of future generations. So we don't want to live on behalf or at the costs of future generations. We need to make sure that also future generations will be able to enjoy all the services, the energy supply, the natural environment that we have today, and also be able to have stable and friendly, welcoming societies. Sustainability is easy to define and to understand, but how do we make it practical? To make it practical, one of the most prominent approaches is the Sustainable Development Goals. These are 17 goals that address the major sustainability challenges we have today. So the challenges that hinder us from having an equitable and prospering society today, while at the same time taking care of the needs of future generations. So these targets or goals that we have here reach all the way from eliminating poverty to taking care of the life on land and the ocean and making sure we have sustainable and livable cities and communities. So these targets are very broad and they bring down the more general conceptual notion of sustainability down to the practical level where we can then do something in certain areas. What I highlighted here on this slide is the link between the Sustainable Development Goals and energy. There is actually a specific goal for energy. It's goal number 7. It's affordable and clean energy. So here it's in itself a goal that people need access, reliable access to affordable and to clean energy. Clean means here not environmentally polluting. But this is not the only goal of the 17 goals that is linked to energy. There's a few other ones that are directly linked. The first one is goal number 1, no poverty, which translates into people need access to energy. For example, to operate their mobile phones, to have lighting when it's dark, and so on. We have health and well-being that needs electricity to run hospitals, for example. We have economic growth that needs electricity to run factories. We have life on land that has a strong link to energy because of the biofuel issue, the biofuel land use. And there's a few more targets that also have a link to energy, which we also talk more about in other lectures. We can see that there's a strong link between energy use and economic growth. It's maybe one of the most stable societal correlations that we have. As people get richer, so they earn more, they spend more, they also consume more services which need energy for their provision. So there's a straight line. You have more money, you consume more energy. And if we want to continue economic growth, we need to rapidly decarbonize the energy supply, for example, to meet our climate goals to avert the climate crisis. So we will actually in other lectures see how quickly we have to decarbonize our energy supply if we're still growing our economy. So these are calculations we then can have. But we also have strong indication of so-called sufficiency, so that at some point it is enough for a decent life or a good life to only consume a certain amount of energy. So here you see on the right side a plot of the Human Development Index, which is a measure of economic prosperity, of lifetime expectancy, and of literacy over electricity consumption. And you see that a certain amount of electricity, roughly 4,000 units, it's kilowatt hours, are needed per person to reach a high development standard. And then the curve flattens off and you get richer, maybe you have more fancy cars, but your overall human development measured in these basic quantities doesn't change much anymore. So there's a sign for decoupling well-being or human prosperity from energy use. When we talk about goal number 13, climate action, we realize that energy is actually at the heart of the problem. In this graph, you see that we take all emissions and break them down into different countries. So the second ring from the outside ranks emission by countries. So you see China, the United States, the EU, and so on. And then on the outermost ring, you see which sectors contribute to those countries' emissions. And for all the countries, you see that the energy sector is the dominant sector. So making energy available by burning fossil fuels, by harvesting forests, and so on, in almost all countries is a major contributor to the climate change issue. So energy and climate action are probably the most strongly linked sustainable development challenges that we have, and we need to tackle both at the same time. We can look into this issue a bit more in detail in this really interesting Sankey diagram that reallocates global greenhouse gas emissions on the right to first fuels and then final energy services, to devices, to different equipments, to the sectors and to the services provided. So here in one picture we can link 4 different sustainable development goals. So we can see that we have strong contributions to global emissions from transport, buildings, industry and agriculture, and we can also see what devices are responsible. So this is really a key figure to prioritize national measures, right? So you can phase out oil and gas burners, for example. You can do something about the transportation emissions by shifting to electric transportation, for example, and the overall potential of all these different measures can directly be estimated from a graph like this. We also have strong linkage between the energy goal and the goal for sustainable living in cities. On these graphs you see how energy use in cities is correlated with population density. In particular for transportation, we see that as cities get more densely populated, which you can see here on the left graph, the energy use drastically declines. So we see there's a strong correlation between urban form, which is one of the arenas of urban planning, and energy use. On the left side, you also see that cities have a large potential for renewable energies. So not generating somewhere far away, but actually generating them in the cities. For example, by equipping rooftops with solar panels. When you do that, you can harvest, depending on the population density, you can harvest even more energy than you need for transport, for example. So there is even a certain potential for cities becoming self-supplying for energy in certain areas and certain population densities. So we can really get an understanding of how much energy we can harvest in a certain area and how much energy is used in a certain area. And the latter, of course, scales with the population density. So we can put into relation the energy use of people and the energy consumed by people, and the population density determines the regional self-sufficiency of energy supply. We have a strong linkage between the energy goal and the life on land, which I already mentioned. It's the land use of energy supply. And of course, renewable energies have usually much larger land use than fossil energy, which is one of the main reasons why fossil energy was used in the first place, because you don't need much land to harvest a lot of energy. So we are actually in the energy transition to renewable energies reversing or trying to reverse a historic trend, going away from concentrated sources of energy, fossil energy, back to dispersed sources where we need a lot of land. And that has, of course, environmental impacts on biodiversity. It has economic impacts on the people who live there, and these impacts need to be understood, quantified, and then eventually managed. We will now see how we can go from sustainability back to the energy topic. And the solution to disentangle the energy sustainability and energy climate challenge is, of course, to make energy supply more environmentally friendly. And there are different terms in use that we need to understand and also see what the differences between them are. So first, we have renewable energy. Now this is energy collected from renewable sources, and that means these sources can be naturally replenished, so replenished by natural processes on a human timescale. And on the left side you see the major sources here. It's of course solar, wind energy, biomass, and different water energies, and also geothermal heat. And then, slightly different to renewable energy, you have low carbon energy. Usually solar, wind, and tidal and wave energy are also low carbon energy, and also in particular hydropower. And for biomass, it's not necessarily the case. Depending on how biomass use impacts the land use change, the biomass can be also a low carbon energy source, but doesn't necessarily have to be, if you think of palm oil growing from freshly clear-cut tropical forests in Indonesia, for example. Another source of low carbon energy is also nuclear energy, which is not renewable by this definition given above. To tackle the sustainability challenges associated with energy supply, we need an energy revolution. We need to completely rethink the way how we harvest energy to fuel or to operate our societies. And the energy transition is an ongoing major technological and also partly societal transformation to move away from fossil fuels and to go to renewable energy, because this is energy that is by definition sustainable because it's replenished over time on a human timescale. And here you see a world map of how the different countries do in terms of renewable energy supply share. And you see that there's actually quite a few countries who have advanced quite far already in renewable energy supply. These are mostly countries that have a lot of hydropower potential that they can use. And hydropower traditionally is renewable energy that's very easy to use because it's concentrated in large rivers and it's extremely cheap. So these countries have a huge head start when it comes to decarbonizing their energy supply, because some countries, due to the large hydropower potential, are already there. For the rest of us, we have a lot of work to do. So here you see that there are so many strategies that can contribute to reducing emissions from current trend down to what we could call a sustainable development scenario for global emissions. So a scenario that is in line with the global agreement on fighting climate change, the Paris Agreement. And you see there are many measures needed. There's efficiency measures in buildings, in the industries, for example. There's renewable energy supply, of course, and there's also more advanced technologies that we call fuel switch. The best known fuel switch is probably going from gasoline operated cars to electric vehicles. And also everything with carbon capture. So CC stands for carbon capture. For example, capturing the carbon from fossil fuel plants could also be a bridge technology to bring down emissions from fossil fuel combustion temporarily. So there is no silver bullet, no single measure that does it all. It's a combination of measures. It depends on the context which measures are most efficient and which aren't. And it's part of the scientific debate about the energy transition to understand what measures are actually effective, what is their overall potential, and in which context can they be used, and in which context maybe they are not so useful. So it also depends a lot on the culture and the regional and local culture, what energy transition measures would be effective. Overall, we know that there's also many different strategies that need to work together. So it's not just technology, it's not just changing the economic system, it's really a combination of the different measures. So we need legal instruments, we need economic incentives, we need new technologies, and we also need lifestyle changes, and all of them together will help us transition from the currently unsustainable state with the many environmental and social challenges to a state that actually meets many or maybe even all of these sustainable development goals that the international community has put forward. So we learn that energy is at the basis of modern society because it supplies us with the services that we need. And we also understand that energy supply is one of the main drivers of unsustainability, in particular of land use and also of the climate change issue. This is the reason why we need a rapid decarbonization of the energy supply and combine it also with demand-side solution. And this is what we together call the energy transition. So we need to decarbonize our energy supply and also need to think and redesign the way we use energy. And we need to think of the strategies together. It doesn't make sense to develop a fancy technology that is so expensive that nobody uses it. Or it doesn't make sense to go to a country with a certain lifestyle technology that doesn't fit into the local legal or cultural system. So we really need to study those different layers of the sustainability challenges, the legal, economic, technology, and lifestyle layer together. With this broad information and overview, I want to stop here and thank you for your attention.